behavior at the end, aka end behavior. There we go. So I'm going to show you guys a couple different graphs. So here we go. A little faster, please. Okay, all these graphs are kind of related to each other. Okay, can you guys talk to each other about which graphs are mostly related to each other and like give a reason? Ready, set, go. Now I hope you guys are saying that these two right here are probably mostly related, and these two right here are probably mostly related. And the reason is not because of everything that's happening between the arrows, but what's happening with the arrows. Okay, look at the arrows on these two. They're both pointing in the same direction. They're not pointing opposite directions. This one's up, up, and this one's down, down. This one is down, up, and this one's up, down. So these two arrows, these two graphs have arrows pointing in the opposite direction. Okay, end behavior. What the heck is end behavior? End behavior is talking about these arrows. Where are they pointing? Okay, so when you hear the word end behavior, you're thinking left side arrow and right side arrow. Okay, so, but when we're talking math, we don't say left side and right side. We have to get a little more complicated, as you know. This would be as x approaches negative infinity. That's what this says. As we're approaching negative infinity, what would that represent? Left side or right side? Think about that. Left side, because that's where x is approaching negative infinity. And so if you wanted to say right side, you would say x is approaching positive infinity. Yeah? Yeah. So every one of these graphs has a left side and a right side. So you would always write this if a problem ever said, what is the end behavior? You will always say, well, as x approaches negative infinity, and then you say something else. So how do we say up? Because the left side of this graph is going up. How do we say that academically?
Like y increases.
Yes. Now you guys say y. I'm going to say f of x, but you guys know f of x is the same, right? So this is my f of x axis, or aka y axis. We can say on the left side of the graph, f of x is going towards infinity. Yeah. Okay, and that would be true for the right side as well. Correct? Correct. Okay, so I want to give you guys a minute right here, and I want you guys to write the end behavior for each of these graphs. Ready, set, go. I'm going to throw them all up here for you so you guys can peer at them. Okay, I got left and right-hand side for each of these. Okay, so I'm just writing it all out. We have to have left and right-hand side for each of these. And so what would, for this first one, what would the left-hand side be approaching?
The negative.
Negative infinity. What would the right-hand side be approaching? That one would be positive infinity because the arrow is pointing up on the right-hand side. And then on the bottom here, we got the left side is approaching positive infinity. And what's the right side approaching?
Negative infinity.
Negative infinity. And then the last one is negative infinity, negative infinity. Okay, they're both pointing in the same direction.
Oh, so
I hope you guys notice that when we talk about end behavior, the middle part doesn't matter. Okay, we only care about the arrows. Which way are the arrows pointing? Now, earlier we talked about how these guys are related and these guys are related. The reason why they're related is because these would be called odd degree functions, and these are called even degree functions. I should write the word degree for each of those. There you go. There's our degree. Okay, so now let me give you guys two functions right here that you guys can make a call on. Okay, this first function right here, I'm just calling it y. What is the degree of this function? 5. And it's not because the term is first, it's because that is the highest exponent. The highest exponent is always the degree. So if this is a 5, which graphs will we be considering for the end behavior for this function? These guys right here, the odd functions, okay? Now there's a difference between which one we would choose though. And that is determined by the leading coefficient. What is the leading coefficient for this function right here? It is positive 1. It is the number right next to the term with the highest exponent. So because it's a positive 1, this is going to be the end behavior, because that's for positive leading coefficients. The negative leading coefficients would be down here. So if that was a negative 1 in front of the x to the fifth, then this would be our end behavior. That's how you guys figure out if it's what the end behavior is. And this really helps with graphing when you guys are sketching your graphs. Okay. All right, I'm going to throw a negative on this one. we know that the degree of this function is even because it has the 4 right here. Which one would it be? If there's a negative in front, it would be the bottom one. That's right, because this one, the top one is where we would have a positive LC, and the bottom one is where we have the negative LC. So I have a cute little chart to give you guys. So here's our cute little chart here. I got my degree, my leading coefficient, even, odd, and this is all the end behaviors that I put up here. So like degree is either even or odd. Okay, even is these two end behaviors, and the odd would be one of these. If your leading coefficient is positive, then it's going to be one of these two graphs. If your leading coefficient is negative, then it's going to be one of these two graphs. Okay. Now I remember even and odd really quickly, actually, because I think of x squared and x to the third. X squared, you guys know what x squared looks like, right? Yeah. X squared goes like this. Okay. The end behaviors point in the same direction. So even always points in the same direction. And then I also think of x to the third for my odds. This one goes like this. Now what's kind of neat is all the odds and all the evens, they follow like a similar pattern. Like if you had x to the fifth and nothing else, then it kind of looks the same. It just goes against the x-axis a little bit more. Okay, so the end behavior is still the same than this one. See how they're kind of the same, just a little different. Anyways, that's how I remember the end behaviors. Odd is always kind of like an N. It's pointing down then up, and then you can flip the N upside down if you have a negative LC. And I think that's it. I think that's all I can say now. Yep, that's it.